All right. Again, my apologies for today and the difficulty that I had and technology not working. So, if you look in the Blackboard folder, and just a quick note to my students, this is for experimental design and technical writing, but I teach two sections. So I have content up in one of my Blackboard folders, but I'm only going to post the video once because you guys are both doing the same thing, just at different times. So as I walk through this, in case you see 291.02 and you're in the O1 section, or vice versa, it's not a problem. You're both getting the exact same content. So if you look through the folder, first of all, you should see a couple things. A lot of things are regarding the memo. So there's an example, there's a rubric available for you, and there's a lecture. All of those I'm going to cover in a video specifically to the memo. What I want to cover today is the accuracy versus precision and the data that is available. The other thing I want to cover is the professional email, because a professional email is due by 11:59 on Thursday. And so the goal of the professional email is to be written as if you were writing to a superior. So imagine I'm your boss and you're going to publish a memo on behalf of the engineering department that will be released to the general public. That's your memo assignment. Before that happens, if you were working in an engineering setting, you would probably run it by your manager. And this could be done a couple different ways. And we've talked about formal and informal feedback. So one of the ways that you could run something by your manager is to send an email giving your ideas of what the memo was going to cover and then solicit feedback or guidance. Because this is to a superior, you should be using proper salutations. So hello, Dr. Ely, or just Dr. Ely. But there should be some sort of salutation at the beginning, just like you would in a letter. And then the closing can be thanks or awaiting more information, looking forward to your response, anything like that. But you're going to close with a specific closing, comma, your name. And so, of course, proper sentence structure, paragraph, spelling, grammar should all be followed. But the idea is you're giving your boss a heads up on what's going to be in the memo and how you're approaching the memo prior to actually publishing it to the entire company. And oftentimes, your boss won't necessarily need to proof your finished document, but they certainly want to know your intentions and be able to provide some input into that process. And so that is the professional email assignment. So it's important for you to have your data and for you to have looked at your data, but you don't have to have your memo written yet. You just have to know what you're looking to say. And so, as I said, I'm going to go through accuracy and precision. We're going to talk about the data, and then that should be plenty of information for you to go ahead and conduct your email, because your email is a reflection of what you did and the data and what that might mean. The memo, on the other hand, will be a formalized document that follows a specific template, and that will be in the second video posted to this content area. So without further ado, let's go ahead and look at our lecture for accuracy and precision. Um, so when we talk about accuracy and precision, one of the things that we want to keep in mind is that these are not identical terms. There are two words because they have two different meanings. Accuracy is looking at how close the measured value is to the true value. So you go to a carnival and it says, I can guess your weight. And they say, you weigh 130 pounds and you actually weigh 150 pounds. Their guess would be inaccurate. Most likely, they shave some pounds off because they want you to be happy with their answer and feel thin. But the idea here is that accuracy is the difference between what the true value should be and how close you measure to that value. So measurement error is looking at the amount of inaccuracy, and you'll see that it functions as a percentage of what you did compared to what you should have gotten. Precision, on the other hand, is looking at the reliability of one measurement to another. In this case, we have a certain measurement of uncertainty, which could be human error. It could be the measuring device. It could be using different measuring devices. Like you have someone use two different sets of calibers to measure the same piece in a machine shop. And one set of calipers has actually been zeroed and is within reliable tolerances, and it has been validated to be working. And the other one was at the back of a drawer. It's been dropped a couple of times. It's not working as well. So the person might do the exact same thing the exact same way and get two different measurements. That's when we're looking at precision to say, if they do it the same way every time, are they getting the same results? And so, all in all, when we look at measurement uncertainty, we're talking about both inaccuracy and precision, because we're going to look at how far we are from that true value, and then also how often are we far from that true value. So if you look at this slide, you can see that there are a couple different examples, and the classic throwing darts at a dartboard or bullseye for target practice are the traditional images for accuracy and precision. And so let's start in the bottom right-hand corner and say high precision and high accuracy means you hit the target every time. So imagine these are your playing cards and you're throwing them into that center ring. Are you getting them in that center ring every time? So the next thing you see, if you go directly above it, still on the right-hand side, is low accuracy, high precision. So this is the person that kind of shanks the cards off to the left. You're throwing them in the same place every time. They're landing really close together, but they're not where you want them. If we continue around the circle, we see low accuracy and low precision. So they're scattered all over the place. There's no rhyme or reason. There's no trend to be seen. And then finally, coming down to the bottom left-hand corner, high accuracy, low precision. We see everything's clustered around that center, but they're not repeatable. We don't have two in the same place even once. And so that gives us an idea, if you think back to the picture or if you have your work in front of you throwing the playing cards, did you see areas of accuracy and precision? That was the point of the experiment, so hopefully you did. Now maybe yours looks like the top left-hand side and it's low accuracy and low precision. Several of you were phenomenal and actually got almost half the cards into the bowl. High accuracy, high precision. A lot of you were somewhere in between, and we'll look at that when we look at the class data. But the goal is to understand that we want to have both high accuracy and high precision, because if I can have something that's repeatable over and over, but it's not the result I want, I'm still not getting a good result. If you think about working in manufacturing and you see the same mistake happening over and over, you still have to rework that part. So the fact that you're getting the same result over and over, or high precision, doesn't mean that you aren't having to do the rework. You need both to be successful. So if we were going to calculate general accuracy, we would say, well, what are the total number of successful tosses divided by 52? So this is a general measurement of how close your cards, and you see it's out of 52 cards, so this is just your personal data. How close were you to getting the cards in? So total successful tosses out of 52. Then general precision, we're going to count anything within ring 1 or within 12 inches. That should be the same standard whether you did frequency for rings or you did actual measurements. If it's 12 inches or less or within ring one, we're going to consider that a win. Maybe it wasn't in the pot, but it was close. It was real close. So we're going to say, yes, we're getting to the area that we want to get. We're not all the way there, but we're close enough. And so one of the things that you're going to compare is you're going to look at your specific data for just your 52 cards and compare that with the class totals, which is why we need the Excel spreadsheets that I posted for you. And so everyone should be able to do that the exact same way. Regardless of how you collected the data, you should know how many successful tosses you had out of the 52 cards, and then compare that with the percentage for the class successes, and then how precise were you for your 52 cards, and compare that to the class general precision. We're going to have a couple other measurements depending on what sort of data you collected. And so we're starting with actual measurement data. So you have things in inches. So you're going to calculate the difference between your expected value and the measured value. So the expected value should be that 48 inches. That's 48 inches away from you. And then the measured value was that distance from the leading edge of the card to the bowl. Those are the distances you measured. And so when we look at the data, you'll see that a lot of the distances, the majority of the distances, are 1, 2, 10, 12, 15, right? Because they're close to the bowl. So that distance you have is how far you were between where you wanted to be. That expected value would have been 0, and the measured value, how far you are away. And you're going to calculate the mean of those differences for your data. Because what we're looking to see is we're saying, well, how do we see the average distance and the average standard deviation for your data? Then when we calculate the standard error, you're going to use the standard deviation that you calculated, and Excel has formulas for all of this. I'll show you this in a second. So you'll use Excel to calculate the standard deviation. You don't have to do it by hand. And then you're going to divide it by the square root of n. And our n is 52 because we had 52 cards. So you divide by the square root of n, and that will give you the standard error for your specific work. When you look at your mean, standard deviation, and standard error, I want you to compare that to the larger group. And so for the larger group, you're going to take the standard deviation, which is already actually given to you on the spreadsheet that's been uploaded, but then you're going to have to divide by the square root of n, not by 52. So n is also available in that spreadsheet, so you have all the data you need, and you're going to compare your mean, standard deviation, standard error with the class mean, standard deviation, and standard error. And then the relative error is looking at that average distance divided by 48, because 48 inches would have been in the bowl. So your average distance divided by 48 is going to give you the relative error, the average relative error. Now, if you did frequency data, you're going to count the frequency per ring, and you're going to calculate the cumulative frequency per ring, and then you're going to calculate the cumulative frequency percentage for each ring. And you're going to compare that with the bigger group. And again, I'll show you on Excel where we're going to do this. Then you're actually going to calculate the weighted relative error for each of the rings. And what you're looking at is you're going to say, so if you did ring 1, that was everything between 0 and 12. So the midpoint of that distance is 6. So if you do 6 divided by 48, that's the distance, the relative difference of error. And then you multiply it by how many cards were in ring 1, and that will give you the weighted relative error for just that factor. And then you can calculate the average for all of those rings. So let's look at the data, because this will make more sense with the data in front of you. So if you haven't used Excel a lot, you'll see that I have 3 tabs going across the bottom. First is raw data for the measured distances. And then I also did frequency, which could be helpful to you. So this is class. This is not just your data. This is all the data for the entire class. And so you see that there were 412 cards that were recorded. Um, the average distance from the bowl was 13.5 inches, and the standard deviation was 9.8. So standard error, I said, was standard deviation over n. So in this case, it'd be 9.8 divided by the square root of 412. So that you take your data, and to do the count is just the count formula. If you click on formula, and in my auto sum, count is always up there, average is in there. And then if you click on more functions and go to statistical, you'll see standard deviation P, STDEV point P. That is the standard deviation formula. So for each of these, count, average, standard deviation, you have that for all of your data. Then for the class, I also have the ring data. The ring data is very simple because I'm just dividing it into the rings: 0 to 12 inches, 13 to 24, 24 to 36, 37 to 48, beyond 48. And you have a total there as well. So if I wanted to do the cumulative, I would say the cumulative for 0 to 12 is 59. And then the cumulative for 0 to 12 and 13 to 24 would be 119, because I've just added those two together. And then I add 119 to 36, and so that's 155. Add 155, 18 to that. So that is 173. Obviously, I didn't do this already. Add 3 to that, 176. Good, it came out right. So my total of all cards equals the total there. So now I can do percentages. And so percentages, I would do the field C12 and divide that by 176. And then I would just continue that formula. And you see that the grand total is 100%. And so you can see that my cumulative distribution, frequency distribution percentages, that 33% of the cards were within 12 inches, 67% of the cards were within 24 inches, 88% of the cards were within 36 inches, 98% of the cards were within 48 inches, and 100% were within all of the cards that I threw. This is the same thing that you'll do for your data. So you'll take each of those rings, you'll count the frequency for each of those rings, you'll create a cumulative sum for each of those rings, and then you'll create the cumulative percentage for each of those rings. And you'll compare that to this class-wide data. Then for success and failures, I have this, all of the data from everyone who reported data. And so you see that the percent of success for the class was 17.7. So that means we've got 18.3 or 82.3% failure. So you'll look at your own personal failure rate and say, how does my failure rate compare to 17.7%? Was I higher? Was I lower? And that's what all these comparisons are. These are saying, you know, in a class where we had multiple data points being collected, everyone had the same objectives, everyone had the same setup, everyone had the same equipment, basically, and we're looking to see how did our individual performance compare to the group. And so I've given you all the data that you need to compare your individual performance to the group. And the question is, are you more accurate? And are you more precise? So, do you get more successes than the group? And do more of your cards fall within the first 12 inches than the group? That's the question. So, from this data, you are going to write 2 documents. The first one is going to be just the email. When we get into class next week, and in the next lecture, I'll tell you a little more about the memo. but we'll talk a little bit about how we can visually display the data as well when we come together next week. For the accuracy and precision, email. Knowing the raw data is plenty to email your supervisor and give a general feel for what the performance was and what action steps might need to be taken. So if I was looking at a procedure that had a 17.7% success rate, that's abysmal. We definitely need to improve that. But we can also say, well, compare that to our precision. If we look and say maybe 50%, let's see what the ring method showed us. Yeah, 67, close to 68%, we're within 24 inches. So we're actually not doing terribly. They're not all getting into the pot, but they're really getting close to the pot for the most part. And maybe our focus is trying to get these remaining outliers closer to the center, and that's what we should be working on. So that in all is what we're looking at. So when you go to Blackboard, make sure you review what's supposed to be in the email. Make sure you look at the class-wide data, and then make sure that you review the lecture if you need any assistance, or this lecture video for the calculations that are going to be required in your memo. For the email, it can be much more general discussion, but it's helpful to know the bottom line. How accurate are you? How precise are you? So that's it for this video. And then the next video, we'll talk about the memo.